Hello, everybody. Today I'm excited to provide an overview of the pioneering work and lasting legacy of computer scientist Stephen Arthur Cook. Cook was born in 1939 in Buffalo, New York, where he attained his bachelor's degree in computer science from the University of Michigan in 1961. Cook went on to earn a master's degree from Harvard in 1962, followed by a PhD from Harvard in 1966. After a brief assistant professorship at the University of California, Berkeley, Cook joined the faculty at University of Toronto in 1970 as a professor in computer science and mathematics department. He was granted the honor of the Distinguished Professor in 1985, 15 years after he joined Toronto. It was during his professorship at Toronto that Cook published his seminal paper in 1971 titled The Complexity of Theorem Proving Procedures. This groundbreaking paper formally defined the concepts of polynomial time reductions, now called Cook reductions, and clearly formulated the P versus NP problem. You may ask yourself, what does that mean? Well, the P stands for polynomial time and refers to the class of the problem that can be solved in polynomial time, meaning that the time to find a solution scales polynomially based on the size of the input. This implies an efficient solution exists. The NP stands for non-deterministically polynomial time and refers to the problem where proposed solutions can be quickly verified in polynomial time, but the actual solutions may take longer to find. An example of this would be the traveling salesman problem. Given a list of cities and the distances between each pair of cities, the problem is to find the shortest possible route that visits each city exactly once and returns to the original city. This problem is in NP because if someone gave you a possible route, you could check in polynomial time whether it is a valid route that visits each city once and verifies it in the shortest path. However, there is no known polynomial time algorithm to find the shortest route. As the number of cities grow, the number of possibilities also grows exponentially. So the traveling salesman problem is thought to be an NP but not an N. We can verify a solution quickly, but we cannot find the optimal solution quickly. This is why it is NP complete. Problems that are NP complete are thought to be intraceable and unlikely to have efficient solutions that run in polynomial time. The distinction between N and NP highlights a fundamental question. Are there problems that can be quickly verified but not quickly solved? Cook's paper was the first formal proof establishing the existence of complexity class P versus NP. This work was soon after independently confirmed by Russian mathematician Leonid Levin. The question of whether P versus NP remains one of the biggest unsolved mysteries in computer science. Resolving this question either way would have profound practical implications. The Clay Mathematics Institute recognizes its importance and has offered a $1 million prize for its solution. Some examples of how proving P versus NP would revolutionize computing is it would enable the development of more optimal and efficient algorithms for complex problems. It would break most modern cryptograph schemes that rely on difficulty of certain problems. It would vastly accelerate breakthroughs in artificial intelligence by speeding up model training. And finally, it would allow more performance and energy-efficient computer hardware design. Due to the significance of his work on computational complexity and P versus NP, Cook has been widely recognized. In 1982, he was awarded the prestigious Turing Award, considered the equivalent of the Nobel Peace Prize in computing. Cook has also been elected to the prestigious scientific organizations, including the Royal Society, the National Academies of Science, and the American Academy of Arts and Sciences. So, in summary, Stephen Cook made a seminal contributions of defining complexity theory and formulating the P versus NP problem, solidifying his legacy as a pioneering computer scientist. The importance of his work continues to be recognized today through accolades and prizes.